All right. So before we can talk about managing strings with pointers, we need to just understand how strings are stored on the memory, right? So just to briefly go recap on our managing memory video, right? If you haven't watched it, I would recommend it you watch it so that you can understand the concept and the syntax, right? So we said that whenever we create a variable, a char variable, it takes up 1 byte, and that is how essentially it's stored along with its address, right, in memory, right? And then for integer variable, it takes up 4 bytes, as we can see, right? It is how it will be stored, right? And then for a string variable, right, the size of a string variable is actually flexible, right? And we'll see how that works, right? But let's just see how it's actually stored on the memory, right? So we say that an array, or rather, I'm getting ahead of myself, right? We say that a string is essentially an array of characters, right? So I know that we haven't touched on arrays, but essentially it is just it just groups those characters, right, and just breaks them into individual characters, right, and then stores them in the memory, right? Let's just see how that's done, right? So how this would be stored on memory, we can just go ahead and type h, right? This is essentially how this variable will be stored on the memory, right? So we said that the memory is rather the size of a string is very flexible, right? Meaning it can change, as we can see that this is now 5 bits, right? It took up 5 bits. You can imagine that longer words would, rather longer even sentences would take up more bits in memory, right? So that is why we say that majority of our strings are stored on the heap, right? Why is that? Because we say that the size of a string can actually change, right? The size of a string can actually change in on the memory, right? And that's why we need to store it on the heap. Why? Because remember we mentioned in our previous video that the stack memory is essentially fixed, right? When the program starts, it's fixed, it cannot change, right? So but we're talking about now, we're introducing a variable that its size can actually change, right? And I want you to not be confused about two things, right? We're saying that the size can change, right? Not the value, right? The value can also change, but the reason, you'll understand why I'm saying this, right? In a second, right? We're saying the size of a string can actually change. We're not talking about the value right now. The size of the string can actually change, meaning if we were to add the value q, right, what is going to happen is that we're going to have that, right? That's, I don't know what that spells, but yeah, essentially that's the new word, right? We can see now we used 6 bits. The size has changed, right? The value has changed. We can see that, but that's not really that important right now. But the size has changed. With the value 4, I mean rather with the integer variables or any other variables, chars, integers, right? The size does not change. The value can change, the size does not change. So that means that if we change this value 5, right, and we made it 5, the bits that we're going to use is still going to be 4. That's not going to change throughout the whole program, and that is why this one can easily be stored on the stack memory, right? Because it does not change. The value can change. This would, I think, I don't remember my bit numbers off my head, but I think this would be 1 yeah, we just change that to 1. I'm not sure, honestly, right? But that's essentially the importance of the difference between string variables and other variables, right? The size of other variables does not change throughout the whole program, right? But the size of this string variable, essentially, it does change, right? So we need to that's something we needed to be aware of, right? Another thing that we need to be aware of with string variables is how we read them, right? So in our previous video, we mentioned that the computer knows, right? It knows how to read the memory, right? So let's just give an example with the char variable, right? So how the char variable is going to be read, right? It's one address. So it's the computer is literally going to go to the address and retrieve that value, and it's done, right? But with an integer variable, right, what it's going to do, and I think this size is, let me just move that address there, right? Yeah, let me just remove that address there so we can see properly. It stores the address of the first byte, right? And it knows, and remember, this is important, it knows that to its right to the right of this, I need to read at least 3 times. And that is why we say that the size does not change, right? No matter the value. In this case, the size does not change. Meaning every time, no matter the value of the integer, it's going to read this and then read whatever is to the right 3 times. It knows that it never changes, right? We said that with other variables like a short, it will probably read this and read once to the right, because it only uses 2 bytes, right? But that's not really that important with in terms of short and long. But yeah, that's essentially how it reads, right? That's very important because of what? The size is fixed, so it knows that when it reads, it knows exactly what to read. But with string variables, it does not know where to stop, because it just keeps reading. It does not know. Remember, we said that the size of it is very flexible, so we cannot tell it read strictly 4 to the right, because this size can actually change. And that is why we introduced the null terminator. We said that every string, automatically when you create a string, it is going to store the string just like this, and then it is going to automatically have a null operator, a null terminator. Let me just expand that so we can see how it's actually written. So that is what we call the null operator, right? So how the computer is going to read this, it does not need to actually know the size of the string when it reads it. It just starts reading from the first address, which is stored here, right? And it just reads anything to the right, right? It's going to read like this until it reaches the null terminator, and it knows what the string has come to an end, right? Without the null terminator, you can imagine if we had another string, maybe the string is yes. What it's going to do is that when it reads, it's going to read everything, right? Because it wouldn't know where to stop. Because remember, we talked about the flexibility of the size of a string, right? So we essentially wouldn't know where to stop, right? So that's the importance of the null terminator. So let's just go ahead and put that null terminator back. Right, and this is going to be very important because that's essentially how we can know that we have reached the end of a string, right? When we start manipulating strings, right? All right, so let's just see how we can go about manipulating strings with pointers, right? So before we do that, I want us to be aware of 2 definitions of strings, right? And this is going to be very important, right? So when you create a string the normal way, right? So we just go ahead and say string, let's give it the name my string, and give it the value hello. And then the other way of creating it. All right, so the difference between the two is that, remember we said that strings both live on, right? Yeah, strings essentially live on the heap memory, right? So the difference between these 2 declarations is that this one, right? What's going to happen, remember what we said about the heap memory, is that we allocate space, and then we have to essentially go and delete that space, right, on the heap memory, right? It's very important that we delete it so that we don't experience memory leak, right? When we define it this way, right, this definition of a string essentially does that automatically for us, right? So we know that with stack memory, that's what it essentially does. It allocates and then deletes automatically, right, once the function call. It is a similar thing with this definition of a string on the heap memory. After it's done, it will deallocate the memory automatically, right? But with this one, which is something we're actually familiar with, right? When we create memory on the heap, right, we have to go again and delete it, right? So this is going to be very important. We need to distinguish between the two, right? So let's go ahead and see how we can actually play around with the strings, right? So what I want to do is essentially write a program that prints out each single letter within the word hello, right, within this string that we created, right? So I'm just going to go ahead and work with this one, with the pointer one, right? Just going to delete this one and rename the string, right? So we said that a string is essentially an array, right? An array of characters, right? It breaks down this word, right? In this case, this word is and it breaks it out into a single character. So we have HELLO, right? So we can essentially index into those specific words, right? I will talk more about indexing when we actually work out with arrays, right? But just know that for now that it's an array that we can actually index into, right? We can index into those specific values, right? So what I want to do is essentially just print HELLO separate, right? So how we go about doing this, we're going to say while, we're going to use a while loop, and we're going to have a condition, right? This condition is going to check, right, whatever position we are at, we're always going to check, are we not at the null terminator, right? That's very important. Why is that important? Because once we reach the null terminator, we know that's the end of the string. We don't need to check anything else. Anything beyond that could be any other variable that we don't really want to touch in this case, right? So let us see how we're going to go about this, right? So we're going to say our string, right? How we index into a string or an array in this case, right? This is essentially, remember, this is an array of characters. We're going to say the two square brackets, and then we're going to have the position that we want. So in this case, let us start with position 0, right? What I need to do, essentially, wrap this up, right? So we're going to say we want to index at position 0, right? We want the character at position 0. So how computers start counting is that they count from 0. It's going to be 0. Let's just use it on this example. It's going to be position 0. It's going to be position 1, 2, 3, 4, right? Just like that, right? So it starts from 0. Very important that we know that it starts at 0, right? So we're going to start at position 0 and then keep increasing, right? So the condition that we're going to check is that as long as wherever we are at that specific point, we are not at the null terminator, right? So until we reach the null terminator, we can continue doing this, right? So that's essentially the condition. So remember, we actually want to go through each and every single what we want to do is go through each and every single character, right? So we'll see how we can actually set that up, right? So what I want to do is essentially print print the character that we are at the current position that we are at. Let's go ahead and do that. All right, so now, as of now, we're only printing one character, right? And this would essentially be an infinite loop because it will print over and over again, right? So we need to think strategically, right? So remember, we want to change to the next character after every loop, after one loop. So what we can do is essentially go create a variable I, give the value 0 because that's where we want to index. That's the first position, that's 0. So we're just going to replace the 0 with I in this case. So essentially, we're going to start by printing at position 0, right? And then we're just going to keep updating the value of I, right? So essentially, we just keep updating the value of I, right, until, right, the position that we are in, right? When we go to that position, right, more specifically in this case, it's going to be position 4, right? When we get to position 4, when we're going to print O, right? But after position 4, we're going to meet the null terminator, and that's where we're going to stop, right? So that's essentially how we can go about indexing into each and every single character of a word that is given, right, with a string, right? So let's just go ahead and console log that so that we can see the result, right? As we can see, it prints that, right? It prints what we wanted it to print, right? So that's one way of doing it. That's one way of indexing into a word, right? The other way is using what we call point arithmetic, right? So a pointer arithmetic, right? So how it works is that the pointer arithmetic just simply shifts a pointer, right? A pointer, or the address of a pointer, into a new pointer so that we can print what is on that specific address, right? So I know that when I say it, it becomes a bit difficult to understand. Let us see how we can actually implement it, right? So we're saying that our pointer is pointing, right? We have a pointer, right? Sorry for that. We have a pointer that's going to be pointing at this specific address, right? At the first letter, right? What we want to do is we want to shift that same pointer to E, and then after shifting that pointer to E, want to shift it to L and continue just like that. We're shifting the point, right? We're no longer using that indexing, we're shifting the point, right? So what's important is the reason why I said we needed to talk about the definition of a string, right? More specifically, this definition of a string is because we need to remember something about the heap memory, is that we need to delete or deallocate that memory once we are done with it. We cannot keep it there forever. Otherwise, we're going to experience memory leak, right? So when I say that, I'm sure it's supposed to be clicking in your head that if we move a pointer, right, to a new address, that means we lose that initial address forever, right? And that can be dangerous, right? Because we can no longer go back and say we're going to delete it, right? So if we move the original pointer, we're going to lose the address of the original pointer, right? That means we can no longer delete this memory. It's just going to stay there forever and ever, right? Until the program ends, right? And that may cause some memory leak, right? So let us see how we can actually manipulate this, right? So that we can actually essentially manipulate the string but keep the original address. So what we can do is we're going to create a pointer, a character, single character pointer that is going to point exactly here, exactly at the first character, right? And then with this pointer we can manipulate it, knowing that we have kept this pointer safe, right? Because this one is very important. Why? Because it's pointing at the original address, which we're going to need to delete, right? So what I'm going to do is create a character, a single character pointer, name it my char, right? Where is this char going to point? It's going to point at exactly the first position of our string, right? So what I'm going to do is I'm going to point at the exact location, right? So this is our exact location, right? This is the value h, right? This is the value h. We saw that when we're looping over, right? But what's important to note is that this is the value. This is not the address, right? This is the value. This is not the address. But remember what we want to do. We want to be able to, once we're here, once we're at h, we want this address so that we can move to the right. So remember the computer needs to know where it is, right, so that it can move around, right? Otherwise, it won't be able to move around. If it only knows the value, then it will only know the value. It cannot move around. So what we need is essentially the address of that of that specific character. So what we're going to do is use our AND operator that we discussed, right? This is the address the address operator, right? So this gives us the exact address, not the value, the exact address. The address is what we need, not the value, right? So once we have the address, we can go again and create a loop. Now what we need to be aware of is that we are pointing at exactly one character, right? We're no longer indexing into the character. So we can essentially go ahead and access that value, right, at that specific character, and say, we're going to say, while that value is not the null terminator, right? Let's go ahead and do that. While that value is not the null terminator, we can go ahead and follow these instructions. What are those instructions? We can go ahead and print that specific value, that character that we are at that specific address, right? So what has changed now is that we're no longer indexing, right? So remember what we said. We said we want to move our pointer. How we go about moving our pointer? We're going to say the pointer where it is pointing at that specific address, right? We're not accessing the value here. We're accessing the address of the pointer, right? And then we're just going to move to the right once, right? So that's essentially how it is, right? So here, remember, we're accessing the value, and here we're accessing the address, right? And we're essentially just saying, let us move to the right once, right? So that's essentially how we go about working with pointers, right? So let's just go ahead and delete the original pointer, right? So now we can console log this, right? As we can see that it does the exact same job, right? But now we are using what? Pointer arithmetic, and it allows us to be more comfortable with manipulating strings with pointers, right? So that's essentially how we can manipulate strings with pointers. So we have reached the end of our episode. If you enjoyed this episode, you can go ahead and leave a like, subscribe if you want to stay tuned to more videos. Otherwise, cheers.